Welcome to the Whispering Galaxy, where we drift through the cosmos, one gentle revelation at a time. Tonight, we're embarking on a journey that might just unravel the most fundamental assumption you've ever held about reality itself. So find your most comfortable position, let the world outside fade to a distant hum, and prepare to question something so basic that you've never thought to doubt it. Before we begin floating through this cosmic mystery together, I'd love to know where you're listening from tonight. Are you nestled under blankets in a quiet bedroom somewhere in Tokyo? Perhaps you're watching from a cozy living room in Manchester as rain taps against your window. Or maybe you're half awake in a dorm room in Sao Paulo, letting these words wash over you like a gentle tide. Drop a comment and let me know. There's something beautiful about how these quiet explorations connect curious minds across the globe. If you're new to our corner of the universe, please consider giving this video a like and subscribing to the Whispering Galaxy. It truly helps this channel find other wandering souls who enjoy pondering the deepest questions while the world sleeps. And to those of you who've already joined our cosmic family, thank you. Your presence makes these late-night voyages through wonder feel less lonely and more like a shared dream. I should probably warn you that tonight's question might keep you awake longer than intended. But if it does, at least you'll be lying there contemplating one of the most profound puzzles that has ever tickled human consciousness. So settle deeper into whatever soft space you've claimed for yourself. And let's begin with a question that sounds deceptively simple. Is time real? Right now, as you listen to these words, you probably feel time flowing around you like an invisible river. Seconds tick by with clockwork precision. Minutes accumulate into hours. Your heart beats its steady rhythm, marking moments with biological certainty. Everything in your experience suggests that time is not just real, but perhaps the most real thing of all. It's the stage upon which every other experience plays out, the invisible thread that weaves together cause and effect, memory and anticipation. But what if I told you that this feeling, this seemingly obvious truth about time's passage, might be nothing more than a beautiful illusion? What if the flow of time that feels so natural, so undeniable, is actually a trick of consciousness? A story your brain tells itself to make sense of a reality that works very differently underneath. This isn't some philosophical word game or abstract speculation. It's a question that sits at the very heart of modern physics, where our most successful theories paint a picture of reality so strange that it challenges everything we think we know about the nature of existence itself. Think about it for a moment. When you remember yesterday, where exactly is that yesterday? When you anticipate tomorrow, where does that future exist? And this present moment you're experiencing right now, this very instant as you hear these words, how long does it last? A second? A millisecond? The more closely you examine it, the more elusive it becomes, like trying to grasp smoke with your bare hands. For most of human history, time seemed straightforward enough. The sun rose and set, seasons cycled, people aged, and everything moved forward in an orderly procession, from past through present toward future. Time was simply the background against which life happened, as obvious and unquestionable as the air we breathe. But then something remarkable occurred in the early 20th century. A young patent clerk named Albert Einstein began playing with some seemingly innocent equations about light and motion, and in doing so, he accidentally shattered humanity's comfortable assumptions about time forever. What he discovered was that time isn't the fixed, universal backdrop we thought it was. Instead, it's flexible, relative, and deeply intertwined with space in ways that defy common sense. Einstein showed us that time can stretch and compress, speed up and slow down, depending on how fast you're moving or how deep you are in a gravitational field. He revealed that there's no universal now that everyone shares, no cosmic clock ticking away in the background. Instead, each observer carries their own personal time, their own private rhythm through the universe. This was just the beginning. As physicists dug deeper into the fundamental nature of reality, they discovered even stranger things. Quantum mechanics, that bizarre theory that governs the behavior of atoms and particles, suggests that, at the smallest scales of existence, time might not flow at all. Instead, it might be something that emerges from the relationships between things, like the way a melody emerges from the arrangement of individual notes. Some physicists now believe that time, as we experience it, is what happens when we observe the universe from inside it, trapped within its unfolding like characters in a story who can't see the whole book at once. From this perspective, the past, present, and future all exist simultaneously in what's called the block universe, a four-dimensional structure where every moment that ever was or ever will be is equally real and equally present. But if that's true, then what exactly are we experiencing when we feel time passing? What creates that sense of moving from moment to moment? That feeling of duration and change that seems so central to being alive? These questions touch something deeper than physics. They reach into the very nature of consciousness itself, into how awareness creates the experience of flowing through time. The more we learn about time, the more mysterious it becomes. Modern atomic clocks can measure it with such precision that they can detect the tiny differences in time's flow between your feet and your head, caused by the barely perceptible difference in Earth's gravity at those two heights. Yet for all our ability to measure time with extraordinary accuracy, we still can't definitively say what it actually is. Is time a fundamental feature of reality, woven into the fabric of existence itself? Or is it something more like temperature, a property that emerges from the collective behavior of countless smaller parts? Could time be a kind of cognitive illusion, a way our brains organize information to create the narrative structure of experience? Or might it be something else entirely? Something so foreign to our usual ways of thinking that we don't yet have the concepts to grasp it. These aren't just academic questions for physicists and philosophers to ponder in their ivory towers. They strike at the heart of what it means to be human, what it means to live a life that unfolds in time, to age and change and remember and hope. If time isn't what we think it is, then what does that say about birth and death, about cause and effect, about the very possibility of meaning itself? Tonight, we're going to explore these questions together, drifting through ideas that span from the quantum realm to the cosmic scale, from the ticking of atomic clocks to the expansion of the universe itself. We'll encounter black holes where time stretches toward infinity, and quantum experiments where cause and effect become tangled in ways that challenge logic itself. We'll discover how the simple act of remembering creates a physical trace in the universe, increasing entropy and giving time its arrow-like direction from past to future. We'll explore how biological clocks evolved to keep life synchronized with the rhythms of a spinning planet, and how consciousness might be the universe's way of experiencing time from the inside. Along the way, we might find that the question, "Is time real?" doesn't have a simple yes or no answer. Reality, it turns out, is far more subtle and strange than our everyday experience suggests. Time might be both real and illusory, both fundamental and emergent, both universal and deeply personal. But don't worry about understanding every detail or remembering every concept. This is a journey of wonder, not a test. Let these ideas wash over you like gentle waves, carrying you deeper into contemplation of mysteries that have puzzled the greatest minds in human history. Sometimes the most valuable thing we can do with a profound question is simply to sit with it, to let it change the way we see the world around us. So as we begin this exploration, remember that you're not just learning about time. You're experiencing it, moment by moment, heartbeat by heartbeat. The very act of listening to these words unfolds in time, creating memories that will become part of your personal past. In a strange way, by questioning time's reality, we're also celebrating it, honoring the mysterious process that allows consciousness to exist at all. The universe has been unfolding for nearly 14 billion years, cooling and expanding and complexifying, creating the conditions that eventually led to planets and life and minds capable of wondering about their own existence. You are a temporary arrangement of matter and energy, a brief pattern in the cosmic flow, contemplating the very processes that created and sustain you. The story of how we discovered time's true nature begins in the most unlikely place, with light. For centuries, scientists believed that light traveled through space, the way sound travels through air, requiring some invisible medium to carry it along. They called this mysterious substance the luminiferous ether, imagining it as a cosmic jelly that filled every corner of the universe. But when experimenters tried to detect this ether by measuring how Earth's motion through it might affect the speed of light, they found something completely unexpected. No matter which direction they pointed their instruments, no matter how fast Earth was moving through space, light always traveled at exactly the same speed. It was as if the universe had a cosmic speed limit that nothing could violate. This discovery troubled physicists deeply. How could light maintain constant speed regardless of the observer's motion? When you're driving down a highway and another car passes you, its speed relative to you depends on how fast you're both going. But light seemed to play by different rules entirely, rules that made no sense according to the physics of the time. Enter Einstein, who possessed that rare combination of mathematical brilliance and childlike wonder that allows someone to see familiar things in completely new ways. Instead of trying to explain away the strange behavior of light, he embraced it. What if light's constant speed wasn't a problem to be solved, but a fundamental truth about the universe? What if our assumptions about space and time were simply wrong? Einstein realized that if light's speed is truly constant, then something else has to give. That something turned out to be time itself. When objects move very fast, time literally slows down for them. When they experience strong gravity, time runs differently there too. Space and time aren't separate, fixed stages where events play out. They're woven together into a single, flexible fabric that can stretch and bend and twist. This insight led to what we now call special relativity, and later, general relativity, theories so strange that even Einstein himself sometimes doubted them. They predicted that identical twins could age at different rates, that clocks on mountaintops would tick faster than clocks at sea level, that massive objects could bend the path of light itself. For decades, these seemed like exotic possibilities that might apply only in extreme cosmic environments. But as our instruments grew more sensitive, we began detecting these effects everywhere. The GPS satellites orbiting overhead experience time differently than we do on Earth's surface. Without accounting for these relativistic effects, your phone's navigation would be off by miles. Every time you climb a flight of stairs, you're literally entering a region where time flows slightly faster. The difference is incredibly tiny, measured in nanoseconds, but it's real and measurable. Atomic clocks sensitive enough can detect the change in time's flow between your head and your feet, caused by the minute difference in Earth's gravitational pull at those two heights. This flexibility of time reveals something profound about the nature of reality. The universe doesn't have a master clock keeping everything synchronized. Instead, every point in space and time has its own local rhythm, its own personal tempo. When we say that something happened at the same time as something else, we're making a statement that's only meaningful from a particular perspective. Imagine you're standing on a train platform, watching a train rush past. From your viewpoint, lightning strikes the front and back of the train simultaneously. But to someone sitting in the middle of the train, the light from the front strike reaches them first, because the train is moving toward that light beam. From their perspective, the strikes weren't simultaneous at all. Both observers are correct within their own reference frames, but they disagree about the order of events. This relativity of simultaneity dissolves our intuitive notion of a universal now that everyone shares. Your present moment is not the same as someone else's present moment if you're moving relative to each other. The universe doesn't unfold in a single, orderly sequence that everyone can agree upon. Instead, it's more like a vast musical score where different instruments play their parts at their own tempo, yet somehow the whole composition holds together. But Einstein's revolution was just the beginning. As physicists probed deeper into the quantum realm, that strange microscopic world where particles behave more like waves of possibility than solid objects, they encountered even more puzzling aspects of time's nature. In quantum mechanics, particles don't have definite positions or velocities until they're measured. They exist in ghostly superpositions of all possible states simultaneously. When we observe them, this cloud of possibilities collapses into a single definite outcome. But the act of measurement doesn't just reveal a pre-existing reality. It seems to create that reality in the moment of observation. This raises profound questions about the relationship between time and consciousness. Does the flow of time require an observer to witness it? Is the progression from past to future something that happens in the universe, or something that happens in minds as they process information? Some interpretations of quantum mechanics suggest that the future doesn't exist until it's observed, that reality is constantly branching into new possibilities with each quantum measurement. Consider the famous thought experiment of Schrödinger's cat, trapped in a box with a quantum device that might or might not trigger a deadly mechanism. According to quantum theory, until we open the box and look, the cat exists in a superposition of alive and dead states. The act of observation doesn't just reveal the cat's condition, it determines it. While this seems absurd when applied to everyday objects like cats, it reflects something genuine about how quantum systems behave. The microscopic world appears to exist in a state of pure potential until consciousness collapses that potential into actuality. If this is true, then the flow of time might be intimately connected to the process of observation itself. But there's an even more radical possibility suggested by some interpretations of modern physics. What if time doesn't flow at all? What if our experience of temporal passage is a kind of cognitive illusion, like the way a movie seems to show smooth motion when it's really just a series of still frames flashing in sequence? In this view, called the block universe or eternalist perspective, past, present, and future all exist simultaneously. The universe is like a vast four-dimensional sculpture, where every moment that has ever existed or ever will exist is equally real. Your birth, your childhood, this very moment of listening, and your eventual death are all equally present in this timeless structure. From outside this block, if such a perspective were possible, there would be no flow, no becoming, no passage from one moment to the next, to the entire history of the universe would be visible at once, like a completed novel where every chapter exists simultaneously. The flow of time we experience would be analogous to reading that novel page by page, creating the illusion of progression when we're really just moving our attention through a static structure. This might sound coldly mechanical, but it has a strange beauty to it. It suggests that every moment of joy, every flash of insight, every quiet evening of contemplation, like this one, is preserved forever in the architecture of space-time. Nothing is ever truly lost, because everything that happens becomes part of the eternal structure of reality. Yet even if the block universe is correct, it doesn't diminish the reality of your experience right now. The warmth you feel, the thoughts arising in your mind, the gentle rhythm of your breathing, all of this is happening, is real, is meaningful, whether time flows or stands still. Experience itself might be what creates the illusion of temporal passage, as consciousness moves through the static landscape of moments like a spotlight illuminating different scenes in a vast theatre. This interplay between objective physics and subjective experience points to something crucial about time's nature. Perhaps it's not enough to ask whether time is real. We need to ask what kind of reality it has. Time might be real as a feature of spacetime's geometry, while also being constructed as an aspect of conscious experience. It could be both discovered and created, both fundamental and emergent. The quantum realm offers more puzzles about time's nature. In some quantum experiments, effects seem to precede their causes, or cause and effect become so entangled that it's impossible to say which came first. These aren't violations of causality, but rather demonstrations that at the deepest levels of reality, our ordinary notions of temporal sequence break down. Imagine an experiment where a photon's path through a maze is determined by a measurement that hasn't happened yet. The photon somehow knows which detector will click in the future and adjusts its behavior accordingly. This isn't magic or time travel. It's quantum mechanics revealing that the relationship between cause and effect is far more subtle than our everyday experience suggests. These quantum experiments hint at something even more profound about time's nature. In the deepest mathematical descriptions of reality, time may not exist at all as a fundamental ingredient. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, contains no time variable whatsoever. It's a timeless equation describing a timeless reality. This creates what physicists call the problem of time. If our most fundamental theories suggest the universe is essentially static and timeless, how do we account for the obvious fact that things change, that events unfold in sequence, that the universe has a history? It's like trying to explain how a movie can have a plot when all the frames exist simultaneously on the film reel. One elegant solution is that time emerges from timelessness through relationships. Imagine the universe as a vast network of correlations between different parts of itself. When one part of the universe can be used as a clock to measure changes in another part, time appears. The universe doesn't need an external timekeeper because it keeps time for itself, using the dance of particles and fields as its own internal rhythm. Your heartbeat, for instance, creates a biological clock that measures the duration of other processes. The vibration of atoms in a crystal oscillator creates a technological clock that coordinates modern civilization. The expansion of space itself creates a cosmic clock that marks the age of the universe. Time isn't a river flowing past these processes. It's the pattern of relationships between them. This relational view of time has profound implications for consciousness. Perhaps awareness itself is a kind of internal clock, a pattern that creates temporal relationships within the complex network of neural activity in your brain. When you remember the past or anticipate the future, you're not accessing some external timeline. You're creating internal correlations that give rise to the experience of temporal flow. Consider how memory works. When you recall yesterday's sunset, your brain isn't retrieving a stored file from some mental database. Instead, it's reconstructing a pattern of neural activity that correlates with the original experience. The pastness of that memory isn't determined by when it was encoded, but by its relationship to your current mental state. Memory creates time as much as time creates memory. This might explain why time feels so elastic in different states of consciousness. When you're deeply absorbed in a book or lost in conversation, hours can pass without notice because your attention isn't creating the usual temporal relationships. When you're bored or anxious, constantly checking an internal clock against your environment, time stretches and crawls. The flow of time isn't just something you experience, it's something you actively participate in creating. Dreams offer another window into time's constructed nature. In dreams, temporal sequence becomes fluid. Past and future intermingle. Cause and effect operate by dream logic rather than physical law. And hours of dream narrative can unfold in minutes of sleep. This isn't because dreams occur outside of time, but because the dreaming brain constructs different kinds of temporal relationships than the waking mind. Even our sense of the present moment is more constructed than we might realize. Neuroscientists have discovered that consciousness doesn't process information instantaneously. Instead, the brain integrates sensory data over small windows of time, roughly a few seconds long, creating the illusion of a seamless now. What you experience as the present moment is actually a carefully edited compilation of recent past events, stitched together by neural processes to create continuity. This editing process explains why the present moment feels extended rather than instantaneous. You don't experience reality as a series of discrete snapshots, but as a flowing stream of experience. Your brain is constantly creating this stream by weaving together sensory information, memory, and prediction into a coherent narrative of ongoing experience. The implications ripple outward from neuroscience into philosophy and physics. If consciousness constructs the experience of temporal flow, then perhaps the universe has found a way to experience time through the minds it has created. Biological systems might be the universe's method of transforming timeless correlations into lived experience, static relationships into flowing narrative. This brings us to one of the most beautiful paradoxes in all of science. The more precisely we try to define and measure time, the more elusive it becomes. We can build atomic clocks accurate to billionths of a second, map the expansion of the universe across billions of years, and trace quantum processes that unfold in attoseconds. Yet all this precision only deepens the mystery of what time actually is. Perhaps this is because time isn't a thing to be found, but a process to be participated in. It's not a container that holds events, but the pattern that emerges when events relate to each other. Time might be less like a river and more like a dance, less like a road and more like a conversation between the different parts of reality. The ancient Greek philosophers recognized two different aspects of time that they called chronos and kairos. Chronos is quantitative time, the measurable sequence of moments that clocks track and calendars organize. Kairos is qualitative time, the meaningful moment, the right time, the fullness of time when something significant happens. Modern physics has focused almost exclusively on chronos, but perhaps understanding time fully requires embracing both aspects. Your experience right now embodies both kinds of time. Chronos marks the minutes you've been listening, the biological rhythms of your heartbeat and breathing, the atomic vibrations that power the device playing these words. But kairos is the quality of this moment, the way these ideas resonate with your thoughts, the particular state of mind you bring to this exploration, the meaning that emerges from this encounter between consciousness and mystery. In quantum field theory, the most fundamental description of matter and energy, time appears as a parameter that labels different configurations of quantum fields. These fields permeate all of space, fluctuating and interacting in patterns that give rise to particles and forces. But the fields themselves exist in a kind of eternal present, a timeless realm where all possibilities coexist simultaneously. When we observe these fields, when we perform measurements that collapse quantum possibilities into definite outcomes, we create events that can be ordered in time. The act of observation doesn't just reveal reality, it participates in creating the temporal structure that makes history possible. In this sense, consciousness isn't separate from the physical universe, but is intimately involved in the ongoing creation of time itself. This participatory universe challenges the traditional boundary between subject and object, observer and observed. If time emerges from the relationships between different parts of the universe, and if consciousness is one of those parts, then awareness isn't just witnessing the flow of time, it's helping to create it. Every moment of attention, every act of memory, every flash of recognition contributes to the vast collaborative project of temporal becoming. The universe began nearly 14 billion years ago, in a state of extraordinary simplicity and uniformity. In those first moments after the Big Bang, when space was smaller than an atom and temperatures exceeded anything we can imagine, time itself may have been born from timelessness. The cooling and expansion that followed created the conditions for complexity to emerge. First particles, then atoms, then stars and galaxies, and eventually the intricate patterns of matter and energy that became life and consciousness. Each new level of complexity brought new ways of experiencing and organizing time. The first replicating molecules created biological rhythms that synchronized with environmental cycles. Early life developed circadian clocks that matched the planet's rotation. Nervous systems evolved to integrate temporal information across different timescales. And finally, consciousness emerged with the capacity to remember the past, anticipate the future, and experience the flowing present. In this evolutionary story, time isn't just the stage on which complexity unfolds. It's part of what evolves. Each new form of organization creates new temporal relationships, new ways of correlating events across different scales and durations. The universe doesn't just exist in time, it learns to create time in increasingly sophisticated ways. Your own existence represents the current frontier of this cosmic evolution of temporal awareness. In your brain, billions of neurons coordinate their activity across milliseconds, creating patterns that persist for seconds or minutes, forming memories that last for years or decades. You can imagine timescales from the quantum realm to the cosmic, contemplate events that happened before you were born and scenarios that might unfold after you die. This capacity to transcend the immediate present, to hold past and future in awareness simultaneously, makes you a kind of temporal being unlike anything else we know in the universe. You don't just experience time, you can think about it, question it, wonder about its nature. Through consciousness, the universe has developed the ability to examine its own temporal structure, to ask whether time is real, and to ponder the mystery of its own existence. As we drift deeper into these questions, remember that you're not just learning about abstract physics or philosophy, you're exploring the very fabric of your own experience. The mysterious process that allows moments to unfold, thoughts to arise, and awareness to persist through constant change. The question of time's reality is ultimately a question about the nature of existence itself, about what it means for anything to be real in a universe that may be far stranger and more wonderful than we can imagine. The deeper we venture into time's mystery, the more we encounter a fundamental paradox that has puzzled physicists for decades. While our most successful theories suggest that time might not flow at all, our lived experience insists otherwise with every passing moment. This tension between scientific understanding and conscious experience reveals something profound about the nature of reality itself. Consider what happens when you remember something from earlier today. Perhaps the taste of your morning coffee or the feeling of sunlight through a window. That memory feels like it belongs to the past, separated from this present moment by the flow of time. But according to our best physical theories, that earlier moment still exists somewhere in the four-dimensional structure of space-time, just as real as this current instant. The block universe theory, as physicists call it, suggests that past, present, and future are all equally real, laid out like frames in an eternal film reel. Your birth, your first day of school, this very moment of contemplation, and events far in your future all exist simultaneously in this timeless structure. From this perspective, time doesn't flow at all. Consciousness simply creates the illusion of movement as it processes different slices of this eternal reality. Yet this scientific picture seems to conflict so dramatically with experience that many find it impossible to accept. How can the flow of time be an illusion when it feels so immediate, so undeniable? When you watch a flower bloom or feel yourself growing older, isn't something genuinely changing, genuinely becoming? The universe certainly seems to have a direction, an arrow that points from past toward future, even if our equations suggest otherwise. This arrow of time emerges from a principle that touches every aspect of existence, the second law of thermodynamics. In simple terms, this law states that entropy, a measure of disorder or randomness, always increases in isolated systems. A broken egg never spontaneously reassembles itself. Heat flows from hot objects to cold ones, never the reverse. Energy spreads out and becomes less useful over time. This universal tendency toward greater disorder gives time its apparent direction. But entropy is a statistical concept, emerging from the behavior of countless particles rather than governing individual atoms or molecules. At the microscopic level, the fundamental laws of physics are largely time reversible. If you filmed two atoms colliding and played the movie backward, the reverse motion would be just as physically valid as the forward version. The arrow of time appears only when we zoom out to see the collective behavior of vast numbers of particles. Imagine dropping a single drop of cream into a cup of coffee. Initially, the cream forms a distinct swirl, a region of low entropy where milk and coffee remain largely separate. But gradually, molecular motion causes the cream to spread and mix until the coffee becomes uniformly colored. The cream has dispersed, entropy has increased, and the process is effectively irreversible. You'll never see the cream spontaneously unmix and form a swirl again, not because the laws of physics forbid it, but because the odds are astronomically against such an occurrence. This same principle governs everything from the cooling of stars to the aging of living beings. Your body maintains its organized structure by constantly consuming energy and exporting entropy to its surroundings. Every breath you take, every thought you think, every movement you make increases the total entropy of the universe by a tiny amount. Life itself is a process of creating local order at the expense of greater disorder elsewhere. Memory, too, has an entropic cost. Every time you form a new memory, your brain must physically restructure itself, creating new neural connections and strengthening existing ones. This process requires energy and generates heat, contributing to the universe's overall increase in entropy. In a very real sense, remembering the past helps create the arrow of time that distinguishes past from future. This connection between memory and entropy reveals something beautiful about consciousness. Your ability to remember yesterday and anticipate tomorrow isn't separate from the physical processes that govern the cosmos. It's intimately connected to them. The same thermodynamic principles that drive the expansion of the universe and the evolution of stars also enable the emergence of awareness and the experience of temporal flow. But even as entropy provides time with its arrow, quantum mechanics introduces new puzzles about causality and sequence. In the quantum realm, where particles exist in superpositions of multiple states simultaneously, the relationship between cause and effect becomes remarkably subtle. Some quantum experiments seem to show effects preceding their causes, or causality becoming so entangled that determining which event happened first becomes meaningless. Consider the delayed choice quantum eraser experiment, one of the most mind-bending demonstrations in all of physics. In this setup, photons pass through a double-slit arrangement, creating an interference pattern that suggests each photon somehow went through both slits simultaneously. But here's the twist. Information about which slit each photon passed through can be erased even after the photon has already been detected. And this erasure retroactively affects the pattern that appears. It's as if the photon's behavior in the past depends on decisions that haven't been made yet, as if the future can reach backward and influence history. This doesn't violate causality in any practical sense. No information travels faster than light, and the past can't be changed in ways that would create paradoxes. But it does suggest that our ordinary notions of temporal sequence break down at the quantum level. These experiments hint at something even more radical about time's nature. In quantum field theory, the most fundamental description of matter and energy, time often appears not as a flowing river, but as a coordinate, a label that helps organize different configurations of quantum fields. These fields themselves exist in a kind of eternal present, fluctuating according to probabilities rather than unfolding in a definite sequence. When we make measurements, when we observe these quantum systems, we're not just passively witnessing events. We're participating in the creation of classical history. The act of observation collapses quantum superpositions into definite outcomes that can be ordered in time. In this sense, consciousness doesn't just experience temporal flow, it helps create it through the ongoing process of measurement and observation. This participatory aspect of quantum mechanics suggests that the relationship between mind and time runs deeper than we might expect. If consciousness plays a role in collapsing quantum possibilities into classical realities, then awareness might be intimately involved in the very process by which the universe creates its own history. The boundary between subjective experience and objective physics becomes blurred, revealing a cosmos where consciousness and physical processes are inseparably intertwined. Near black holes, where gravity becomes so intense that it warps space-time itself, time's flexible nature becomes dramatically apparent. As you approach a black hole's event horizon, the boundary beyond which nothing can escape, time dilation becomes extreme. From the perspective of someone watching from a safe distance, your motion appears to slow down dramatically, your image freezing at the edge of the horizon as light from your location becomes increasingly redshifted. But from your own perspective, nothing unusual happens to time's passage. Your watch continues ticking normally, your thoughts proceed at their usual pace, and you cross the event horizon without feeling any temporal distortion. It's only when you compare your experience to that of distant observers that time's relativity becomes apparent. There is no universal time, no cosmic clock that everyone shares, only the personal time that each observer carries through space-time. Inside the black hole, the geometry of space-time becomes so warped that the future direction points inexorably toward the central singularity. Moving deeper into the black hole becomes as inevitable as moving forward in time, suggesting that space and time exchange roles in this extreme environment. The singularity at the center represents not just a point in space, but a moment in time that all infalling matter must eventually reach. What happens at the singularity remains one of physics' greatest mysteries. According to Einstein's equations, density and curvature become infinite, and the known laws of physics break down completely. Some theories suggest that quantum effects might prevent true singularities from forming, replacing them with exotic structures that we don't yet understand. Others propose that information falling into black holes might be preserved on their surfaces, encoded in microscopic fluctuations of the event horizon. Stephen Hawking's discovery that black holes emit radiation adds another layer to the mystery. This Hawking radiation causes black holes to slowly evaporate, returning their mass energy to the surrounding universe over fantastically long timescales. For a black hole with the mass of our Sun, complete evaporation would take longer than the current age of the universe, multiplied by trillions upon trillions. Yet eventually, even the most massive black holes would fade away, leaving behind only dilute radiation and elementary particles. This cosmic timeline extends far beyond anything we can easily comprehend. In about 100 trillion years, long after the last stars have burned out and galaxies have drifted apart, black holes will be among the few remaining sources of energy in the universe. Their slow evaporation through Hawking radiation will provide the final sparks of activity in an increasingly cold and empty cosmos. Eventually, even this will end. The universe appears destined for what physicists call heat death, a state of maximum entropy where energy is distributed so uniformly that no further work can be extracted from it. In this far future, temperatures everywhere will hover just above absolute zero, and the distinction between different regions of space will largely disappear. Time itself won't stop, but with no processes left to mark its passage, it will lose most of its meaning. Yet even in contemplating this ultimate fate, we encounter time's persistent mystery. The universe began in a state of remarkably low entropy, with matter and energy distributed in ways that made subsequent complexity possible. Stars could form, planets could coalesce, and life could evolve precisely because the early cosmos was far from equilibrium. But why did the universe begin in such an improbable state? Why was its initial entropy so low? This question touches on some of the deepest puzzles in cosmology. The Big Bang appears to have started with conditions so precisely tuned that tiny deviations would have prevented the formation of atoms, let alone stars and galaxies. Some theories suggest that cosmic inflation, a period of exponential expansion in the universe's first moments, might have smoothed out initial irregularities and set the stage for subsequent evolution. But inflation itself requires special initial conditions, pushing the mystery back another step. Other approaches invoke the anthropic principle, suggesting that we observe a low entropy beginning precisely because such conditions are necessary for the emergence of observers like ourselves. In an infinite multiverse with every possible initial state, conscious beings would naturally find themselves in regions compatible with their existence. These cosmological questions interweave with the nature of time in fascinating ways. If the universe is one of infinitely many possible worlds, each with different physical laws and initial conditions, then time itself might take different forms in different cosmic domains. Some regions might experience time as we do, with a clear arrow pointing from past to future. Others might have multiple time dimensions or temporal structures so alien that we lack concepts to describe them. Quantum mechanics adds yet another layer to these mysteries through the many worlds interpretation, which suggests that reality continuously branches into parallel timelines with every quantum measurement. In this view, every possible outcome of every quantum event actually occurs, but in separate, non-interacting branches of the universal wave function. The timeline you experience is just one thread in an infinite tapestry of parallel histories. If many worlds is correct, then the flow of time you experience represents just one path through an enormous space of possibilities. Every moment of choice or chance creates new branches, new timelines where different outcomes unfold. The version of you reading these words exists alongside countless other versions, making different choices, experiencing different thoughts, following different paths through the branching structure of quantum reality. This multiplication of timelines raises profound questions about personal identity and the meaning of individual experience. If every possible version of your life plays out in parallel branches, what makes your particular timeline special? Why do you experience this sequence of events rather than any of the countless alternatives? The many worlds interpretation offers mathematical elegance, but at the cost of multiplying reality beyond any hope of direct verification. Biological systems add their own fascinating wrinkles to time's mystery. Living organisms have evolved sophisticated mechanisms for measuring and anticipating temporal patterns, from circadian rhythms that track daily cycles to seasonal migrations that span thousands of miles. These biological clocks operate at multiple scales simultaneously, from millisecond neural firing patterns to annual reproductive cycles. Your own body contains numerous temporal systems operating in parallel. Your heart beats roughly once per second, your neurons fire hundreds of times per second, your cells divide over periods of days or weeks, and your tissues replace themselves over months or years. Each of these processes contributes to your overall sense of temporal flow, creating the rich, multi-layered experience of embodied time. The brain itself appears to construct the experience of temporal flow through complex information processing. Different neural systems track different aspects of time. Some monitor the immediate present, Others maintain working memory of recent events. Still others store long-term memories that can stretch back decades. The integration of these systems creates the seamless sense of flowing from past through present toward future. Damage to specific brain regions can dramatically alter temporal experience. Some patients lose the ability to form new memories, trapping them in an eternal present, where each moment feels disconnected from what came before. Others experience temporal displacement, feeling as though they're living in the past or future rather than the present. These conditions reveal how much our ordinary sense of time depends on the proper functioning of neural machinery. Altered states of consciousness provide additional windows into time's constructed nature. Under the influence of certain psychoactive substances, the normal flow of time can seem to stop, reverse, or fragment into disconnected moments. Deep meditation can create experiences where hours pass like minutes, or where the sense of temporal flow disappears entirely. These states suggest that our usual experience of time represents just one possible mode of consciousness among many. Even in ordinary waking consciousness, time's passage feels remarkably elastic. Childhood summers seem to last forever in memory, while adult years fly by in what feels like months. Novel experiences create rich, detailed memories that make time periods feel extended in retrospect, while routine activities compress into forgettable sequences that seem to occupy no time at all. The psychological present, the window of experience that feels immediate and ongoing, appears to span roughly 2 to 3 seconds, constantly updating as new sensory information arrives. This plasticity of temporal experience hints at something fundamental about consciousness itself. Perhaps awareness doesn't simply witness the flow of time, but actively participates in creating it through the ongoing process of attention, memory, and anticipation. The universe may have found a way to experience its own temporal structure through the minds it has created, transforming abstract mathematical relationships into lived experience. The question of whether time is real thus becomes inseparable from questions about the nature of consciousness, observation, and reality itself. If time emerges from relationships between different parts of the universe, and if consciousness represents one way those relationships manifest, then perhaps awareness and temporality are two aspects of the same underlying process. The universe doesn't just exist in time, it might create time through the act of becoming aware of itself. This brings us to one of the most beautiful paradoxes in all of science. The more precisely we measure time, the more mysterious it becomes. We can build atomic clocks that lose less than a second over millions of years, map the cosmic timeline back to moments after the Big Bang, and trace quantum processes that unfold in attoseconds. Yet all this precision only deepens our wonder about what time actually is and why it seems to flow in the way it does. Perhaps this mystery is not a failure of understanding, but a reflection of time's true nature. If time is not a thing to be discovered, but a process to be participated in, not a container for events, but the pattern that emerges when events relate to each other, then its elusive quality makes perfect sense. We can never step outside time to observe it objectively, because we are time, embedded in its flow, created by its processes. The ancient philosopher Augustine captured something essential about this puzzle when he wrote that he knew perfectly well what time was until someone asked him to explain it. Time is simultaneously the most intimate aspect of experience and the most difficult to define. It shapes every moment of awareness, yet remains perpetually just beyond the reach of complete understanding. This elusiveness might be time's greatest gift to consciousness. If we could fully grasp time's nature, pin it down with perfect definitions and complete equations, we might lose something essential about the mystery of existence itself. The flow of time creates space for wonder, for questions that remain perpetually fresh, for the ongoing adventure of consciousness exploring its own foundations. In quantum field theory, particles are understood not as tiny billiard balls, but as excitations in underlying fields that permeate all of space. The electron field, the photon field, the quark fields, These invisible substrates give rise to all the matter and energy we observe through their complex patterns of vibration and interaction. Time, in this picture, becomes the parameter that describes how these field configurations evolve and change. But here's where things become truly strange. In the deepest mathematical formulations of quantum field theory, time often disappears entirely. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, contains no time variable at all. It's a timeless equation describing what appears to be a timeless reality, where all possible configurations of matter and energy exist simultaneously in a vast superposition. This creates what physicists call the problem of time. If the fundamental description of reality is timeless, how do we account for the obvious fact that things change and evolve? One possibility is that time emerges from correlations within this timeless quantum state. When one part of the universe can serve as a clock for measuring changes, in another part, temporal relationships appear even within and fundamentally a temporal structure. Your heartbeat, for instance, creates correlations with other processes in your body and environment. Neural firing patterns in your brain correlate with sensory inputs and motor outputs. These webs of correlation might be what create the experience of temporal flow from an underlying reality that is, at its deepest level, perfectly still and eternal. This perspective suggests that time might be somewhat like temperature. Temperature isn't a fundamental property of individual atoms. It emerges from the collective motion of many particles. Similarly, time might not be a basic feature of reality, but something that emerges when simple, timeless relationships between parts of the universe create complex temporal patterns at larger scales. If this is correct, then your experience of flowing through time might be analogous to the way a whirlpool appears in a stream. The water itself isn't fundamentally circular, but under the right conditions, the interaction of currents creates a persistent rotating pattern. Your consciousness might be like that whirlpool, a stable pattern of correlations that creates the experience of temporal flow within an underlying reality that knows no such flow. The search for quantum gravity, a theory that would unite quantum mechanics with general relativity, continues to reveal new puzzles about time's fundamental nature. Some approaches suggest that spacetime itself might be quantized, composed of discrete units too small to measure directly. Others propose that space and time might emerge from more fundamental quantities, perhaps from pure information, or from the geometry of abstract mathematical spaces. String theory, one of the most ambitious attempts at quantum gravity, requires additional dimensions of space beyond the three we experience directly. In these higher dimensional spaces, time might behave very differently than it does in our familiar four-dimensional space-time. The flow of time we experience might be a kind of shadow cast by processes occurring in these hidden dimensions. Loop quantum gravity takes a different approach, suggesting that space and time are woven from quantum loops at the Planck scale. Distances so small that the usual notions of smooth spacetime break down entirely. At this fundamental level, time might be granular rather than continuous, composed of discrete moments separated by intervals smaller than anything we could ever measure. These theoretical explorations push us toward a remarkable conclusion. Time, which seems like the most basic and obvious aspect of reality, might actually be one of the most derived and complex. Like consciousness itself, temporal experience might emerge only when simpler components reach sufficient levels of organization and complexity. This doesn't make time any less real or meaningful. Emergence doesn't imply illusion. The wetness of water emerges from the interaction of H2O molecules, but wetness is genuinely felt. The redness of a rose emerges from the way its petals absorb and reflect light, but the beauty we perceive is authentically experienced. Similarly, the flow of time might emerge from timeless quantum correlations, but the moments of joy, wonder, and contemplation it makes possible are completely real. As we drift deeper into these cosmic mysteries, we find ourselves returning again and again to the relationship between time and consciousness. Perhaps this isn't coincidental. Perhaps the mystery of time and the mystery of awareness are really the same mystery viewed from different angles. Both involve the transformation of simple relationships into complex experience. Both create the sense of flow and change from underlying patterns that might be fundamentally static. The universe began as pure energy in a state of extraordinary simplicity and has spent nearly 14 billion years exploring increasingly complex forms of organization. Stars, planets, molecules, cells, organisms, brains, and minds. Each level builds on the previous ones, creating new kinds of order and new ways of processing information. Consciousness might represent the universe's most sophisticated method yet for creating temporal experience from timeless relationships. In this view, you are not just observing the cosmos, you are the cosmos observing itself. Through your awareness, the universe experiences the flow of time, the weight of memory, the anticipation of future possibilities. The questions you're pondering right now about time's reality are questions the universe is asking itself about its own nature through the intricate patterns of neural activity that constitute your thoughts. This cosmic perspective doesn't diminish the intimacy of personal experience. It deepens it. Every moment of consciousness, every flash of recognition, every quiet reflection, like this one, represents the universe coming to know itself in a new way. The flow of time you feel is the cosmos discovering what it's like to exist, to change, to become something more than it was before. Whether time flows or stands still, whether it's fundamental or emergent, whether it exists independently or only in the relationships between things, these questions touch the very heart of existence itself. They invite us to wonder not just about the mechanics of reality, but about the mystery of being aware beings capable of asking such questions at all. As we continue this exploration together, drifting through ideas that span from quantum mechanics to cosmology, from neuroscience to philosophy, remember that you're not just learning about time, you're experiencing it. Each word you hear unfolds in time. Each thought that arises exists within temporal flow. Each moment of understanding represents time creating meaning through consciousness. The universe may be vast and ancient beyond comprehension, but it has somehow arranged itself so that right here, right now, awareness can contemplate its own foundations. Through your questions and wonder, time becomes aware of itself, and the cosmic mystery of existence gains another perspective from which to examine its own profound strangeness. The intersection of time and information reveals one of the most elegant connections in all of physics. Every time you form a memory, every time you process a thought, every time you make a decision, you're participating in a fundamental dance between order and disorder that shapes the very arrow of time itself. Think about what happens when you remember something, perhaps the scent of rain this morning or the feeling of warmth from sunlight through your window. That act of remembering isn't just a mental process floating somewhere outside the physical world. It's a real, measurable event that leaves traces in the universe itself. Neural pathways strengthen, molecular structures change, and energy flows from one configuration to another. This connection between memory and physics runs deeper than you might expect. In the 1960s, physicist Rolf Landauer discovered something remarkable. Erasing information, whether in a computer or in a brain, requires energy and generates heat. Every time you forget something, every time a memory fades or gets overwritten, entropy increases somewhere in the universe. Information isn't abstract. It has weight. It takes energy to maintain, and it costs something to destroy. Your thoughts, right now as you listen to these words, are creating physical changes in your brain that ripple outward into the environment around you. The electrical activity of neurons generates tiny magnetic fields. The chemical processes that sustain consciousness release heat, Even the act of paying attention leaves microscopic traces that increase the total entropy of the cosmos. This reveals something beautiful about the relationship between mind and time. Consciousness doesn't just experience the arrow of time, it helps create it. Every moment of awareness, every act of observation, every decision that collapses possibilities into actualities contributes to the universe's ongoing journey from order toward disorder. In a very real sense, thinking participates in the cosmic process that gives time its direction. But there's something even more profound hidden in this connection. If consciousness requires the constant processing and updating of information, and if information processing always increases entropy, then awareness itself might be what transforms the timeless mathematical structures of physics into the flowing experience of lived time. The universe may have found a way to experience temporal passage through the minds it has created. Consider how biological systems evolved to track time across multiple scales simultaneously. Your circadian rhythms synchronize with the planet's rotation, creating daily cycles of alertness and rest. Seasonal changes in light trigger hormonal shifts that prepare your body for different environmental conditions. Even at the cellular level, molecular clocks regulate everything from DNA repair to protein synthesis according to precise temporal schedules. These biological timepieces don't just measure time, they embody it. The rhythm of your heartbeat, the oscillation of brainwaves during different sleep stages, the periodic firing of neurons that maintain consciousness, all of these represent time made tangible through living processes. Life transforms the abstract coordinate time of physics into the concrete rhythms of embodied existence. Your personal experience of temporal flow emerges from the integration of countless smaller timescales. Millisecond electrical impulses between neurons combine into thoughts that last seconds. These thoughts accumulate into memories that persist for minutes, hours, or decades. The interplay between these different temporal layers creates the rich, multi-layered experience of consciousness moving through time. But consciousness does something even more remarkable. It creates the experience of the present moment. Neuroscientists have discovered that what you experience as now isn't instantaneous, but extends over roughly 2 to 3 seconds. Your brain continuously integrates sensory information across this brief window, creating the illusion of a seamless, flowing present that bridges the gap between past and future. This constructed present moment reveals something crucial about time's nature. The now you inhabit isn't a mathematical point or an infinitesimal instant. It's a created experience, a narrative that consciousness weaves from the constant stream of sensory data, memory, and prediction. In this sense, the present moment is both discovered and invented, both given by physics and made by awareness. Different states of consciousness reveal just how malleable this experience can be. During deep meditation, the sense of temporal flow can slow to a crawl or disappear entirely, replaced by an experience of timeless presence. In dreams, cause and effect operate according to their own logic, and hours of narrative can unfold in minutes of sleep. Under certain altered states, the normal sequence of past, present, and future can fragment, reverse, or blend in ways that challenge our ordinary assumptions about temporal order. These variations in temporal experience aren't just curiosities. They offer glimpses into the constructed nature of time itself. If the flow of time were absolutely fundamental and unchanging, we wouldn't expect consciousness to be able to modify it so dramatically. The fact that awareness can stretch, compress, or even temporarily suspend the sense of temporal passage suggests that the experience of time is more flexible and contingent than we usually recognize. Modern neuroscience has begun mapping the brain networks responsible for different aspects of temporal experience. Some regions track immediate sensory input, creating the experience of the present moment. Others maintain working memory, allowing recent events to remain accessible for conscious reflection. Still, others store long-term memories that can be retrieved and re-experienced years or decades later. When these systems are damaged, temporal experience can become profoundly altered. Some patients lose the ability to form new memories, trapping them in an eternal present, where each moment feels disconnected from what came before. Others experience temporal displacement, feeling as though they're living in the past or future rather than the present. These conditions reveal how much our normal sense of time depends on the proper functioning of neural machinery. But perhaps the most remarkable discovery is that the brain doesn't just passively experience time, it actively predicts it. Consciousness constantly generates expectations about what will happen next, comparing these predictions with incoming sensory data and updating its models accordingly. This predictive processing creates the sense of temporal continuity that makes experience feel coherent rather than fragmentary. Your brain right now is generating predictions about the next words you'll hear, the thoughts that might arise, the sensations you might feel. When these predictions align with reality, experience flows smoothly. When they're violated by unexpected events, attention sharpens and memory strengthens, creating the kinds of vivid moments that feel extended in time. This predictive aspect of consciousness suggests something profound about the relationship between mind and time. Perhaps awareness doesn't just witness temporal flow, but participates in creating it through the ongoing process of expectation and confirmation. The future isn't just something you move toward, it's something you continuously construct through the act of prediction and attention. Quantum mechanics adds yet another layer to these mysteries through the role of observation in collapsing quantum superpositions. Every measurement, every observation that transforms quantum possibilities into classical actualities represents a moment where the future crystallizes out of pure potential. If consciousness participates in this process of quantum measurement, then awareness might be intimately involved in the ongoing creation of classical history from quantum possibility. Some interpretations of quantum mechanics suggest that consciousness plays a special role in determining which of many possible futures becomes actual. In this view, the choices you make, the observations you perform, the very act of paying attention helps select which branch of the quantum multiverse becomes realized. The timeline you experience isn't just one path among many, it's partially created by the process of conscious observation itself. This participatory view of quantum mechanics remains controversial, but it points toward a remarkable possibility, that consciousness and time are not separate phenomena, but intimately connected aspects of how reality unfolds. Perhaps the universe has evolved conscious observers, not just to witness its history, but to participate in creating it through the ongoing process of measurement and attention. The implications ripple outward into cosmology itself. If the universe began in a state of pure quantum potential and has been crystallizing into classical reality through countless acts of observation and measurement, then the arrow of time might emerge from the cumulative effect of all conscious beings throughout cosmic history. Every moment of awareness, from the simplest bacterial response to light to the most sophisticated human contemplation, contributes to the vast collaborative project of temporal becoming. This cosmic perspective transforms our understanding of what it means to be conscious beings in a temporal universe. You're not just witnessing the passage of time, you're participating in its creation. Every moment of attention, every act of memory, every flash of recognition helps weave the fabric of experienced time from the timeless mathematical structures that underlie physical reality. The question of whether time is real thus becomes inseparable from the question of what consciousness is and how it relates to the physical world. If time emerges from relationships between different parts of the universe, and if consciousness represents one way those relationships manifest, then perhaps awareness and temporality are two aspects of the same underlying process. Consider how this perspective illuminates the mystery of personal identity across time. What makes you the same person you were yesterday or 10 years ago when every atom in your body has been replaced multiple times? The answer might lie not in any fixed substance that persists through time, but in the continuity of information processing that creates the ongoing narrative of selfhood. Your sense of being a continuous self moving through time emerges from the brain's remarkable ability to integrate memories, experiences, and predictions into a coherent story. This narrative self isn't a thing that exists independently of time. It's a pattern that exists in time, created and sustained by the ongoing process of conscious experience itself. This view suggests that personal identity and temporal experience are intimately connected. The self is not something that moves through time like a passenger on a train. It's something that emerges from the process of temporal integration itself. You exist as a self precisely because consciousness creates continuity from the constant flow of moments, weaving past, present, and future into a unified experience of being. Death, from this perspective, isn't the cessation of a thing, but the ending of a process. The pattern of information processing that creates the experience of being you would simply cease to continue. But the moments of consciousness you've experienced, the observations you've made, the ways you've participated in the ongoing creation of time itself, all of these remain woven into the fabric of cosmic history. This brings us to one of the most beautiful aspects of temporal existence: the way consciousness transforms abstract duration into meaningful experience. The same interval of clock time can feel like an eternity of boredom, or a fleeting instant of joy, depending on the quality of attention you bring to it. Love makes moments precious. Wonder makes them profound. Presence makes them complete. Perhaps this is why the question of time's reality resonates so deeply. It's not just about physics or philosophy, but about the nature of experience itself, about what it means to be conscious beings capable of transforming the mechanical ticking of clocks into the rich tapestry of lived time. Through awareness, the universe doesn't just unfold, it experiences its own unfolding. The dance between order and disorder that drives the arrow of time finds its most beautiful expression in consciousness itself. Your brain maintains its organized structure by constantly processing information, creating local order at the expense of greater disorder in its environment. Every thought you think, every memory you form, every moment of awareness represents the universe temporarily organizing itself into patterns complex enough to contemplate their own existence. This process can't continue forever. Eventually, the energy gradients that power consciousness will flatten out. The temperature differences that drive information processing will disappear, and the universe will settle into a state of maximum entropy, where no further computation is possible. But for now, in this brief cosmic moment when stars still burn and minds still think, the universe has found a way to experience time from the inside. Through consciousness, the cosmos has learned to feel the weight of the past, the immediacy of the present, and the openness of the future. Through awareness, abstract mathematical relationships become lived experience, timeless correlations become flowing narrative, and the question of whether time is real becomes a celebration of the mystery of existence itself. As we drift deeper into these contemplations, remember that you're not just learning about time, you're embodying it. Each moment of understanding represents time creating meaning through consciousness. Each question that arises demonstrates the universe examining its own foundations through the minds it has created. Whether time flows or stands still, whether it's fundamental or emergent, the experience you're having right now represents one of its most remarkable achievements: awareness, pondering its own temporal nature in the gentle darkness of a cosmic night. As we continue our gentle drift through time's deepest mysteries, we find ourselves approaching perhaps the most mind-bending frontier of all, the realm where time itself begins to break down, where the very fabric of space-time warps and twists in ways that challenge everything we thought we understood about existence. Picture, if you will, a region of space where gravity has become so overwhelmingly powerful that it bends reality itself. This is the domain of black holes, those cosmic monsters that devour light and stretch time until it nearly stops. Near these gravitational giants, our familiar notions of duration and sequence dissolve into something far stranger and more wonderful than science fiction could imagine. Imagine you're drifting toward one of these cosmic behemoths, perhaps carried by a spacecraft that's lost its battle against the inexorable pull. From your perspective inside the falling vessel, nothing seems particularly unusual about time's passage. Your watch ticks at its normal pace. Your thoughts flow at their usual rhythm. Your heartbeat maintains its steady cadence. Time feels perfectly ordinary, perfectly normal. But to someone watching from a safe distance, far from the black hole's gravitational embrace, your journey takes on an almost supernatural quality. As you approach the event horizon, that invisible boundary beyond which nothing can escape, your movements begin to slow from their perspective. Your signals become increasingly stretched and red-shifted, your image appearing to freeze at the very edge of eternity. This isn't some trick of optics or limitation of observation. It's time itself becoming elastic, stretching like warm honey under the influence of gravity's immense pull. What Einstein's equations tell us is that time doesn't flow at a universal rate. It's personal, intimate, shaped by where you are and how you move through the cosmic landscape. The mathematics reveal something even more extraordinary. From the outside observer's viewpoint, you never actually cross the event horizon. You appear to slow down asymptotically, your final moment stretched across infinite duration. Yet from your own experience, the crossing happens normally, unremarkably. You pass through that cosmic point of no return and continue your journey toward whatever mysteries lie within. This paradox reveals something profound about the nature of temporal experience. There is no single objective flow of time that everyone shares. Instead, each observer carries their own private chronometer, their own personal relationship with duration. Near black holes, these private times can diverge so dramatically that the same event, your crossing of the event horizon, both happens and doesn't happen, depending on who's doing the observing. Inside the black hole's interior, space-time becomes so warped that the usual relationships between space and time exchange roles. The direction toward the center becomes like the direction toward the future, inevitable, inescapable. You can no more avoid reaching the singularity at the black hole's heart than you can avoid moving forward through tomorrow. The geometry of space-time itself ensures that all paths lead to the same destination. What awaits at that central point remains one of physics' greatest enigmas. The equations suggest infinite density, infinite curvature, a place where the known laws of nature simply surrender. But many physicists suspect that quantum effects, those strange rules that govern the microscopic world, might intervene before true infinity is reached. Perhaps the singularity is replaced by something else, a quantum bounce, a gateway to another universe, or a structure so exotic that we lack words to describe it. Hawking radiation adds another layer to this temporal mystery. Stephen Hawking's calculations showed that black holes aren't perfectly black, but emit a faint glow due to quantum effects near the event horizon. This radiation carries away energy, causing the black hole to slowly shrink over astronomical periods. For a black hole with our sun's mass, complete evaporation would take longer than a trillion years, a timescale that makes the current age of the universe seem like a brief instant. Yet eventually, even the most massive black holes would fade away, their final moments marked by increasingly intense bursts of Hawking radiation. In the universe's far future, when stars have burned out and galaxies have drifted apart, these evaporating black holes might provide the last sources of energy in an increasingly cold and empty cosmos. The study of black holes has revealed something remarkable about information and time. According to quantum mechanics, information cannot be destroyed. It can only be transformed or hidden. But what happens to the information that falls into a black hole? Does it vanish forever when the black hole evaporates, Or is it somehow preserved in the Hawking radiation that escapes? This information paradox has led to revolutionary ideas about the nature of spacetime itself. Some physicists propose that all the information about what falls into a black hole is encoded on its two-dimensional surface, like a hologram that contains a three-dimensional image. This holographic principle suggests that what we perceive as three-dimensional reality might actually be information stored on a distant boundary, projected inward like shadows on the wall of Plato's cave. If this is true, then the black hole's interior, that region where time becomes space and all paths lead to the center, might be an emergent phenomenon, arising from the complex dance of information on the event horizon's surface. The experience of falling through three-dimensional space and time might be a kind of holographic projection of processes occurring in a fundamentally two-dimensional reality. These ideas stretch far beyond black holes themselves. If the holographic principle applies universally, then our entire three-dimensional universe might be encoded on some distant boundary. The flow of time we experience, the spatial relationships we navigate, the very sense of depth and dimension that shapes our reality, all of it might emerge from information processing on a cosmic screen we can never directly observe. This perspective transforms our understanding of what it means to exist in time and space. We might be living in something analogous to a cosmic simulation, not in the sense of artificial intelligence running on some vast computer, but as emergent patterns in a holographic projection of more fundamental processes. The temporal flow we experience would be real to us, but it would arise from deeper, perhaps timeless structures that exist at reality's foundation. Quantum mechanics introduces its own puzzles about time near black holes. The quantum field theory that describes particles and forces becomes incredibly complex in the curved spacetime around these objects. Virtual particles that normally pop in and out of existence in empty space behave very differently when spacetime itself is warped by gravity. Near the event horizon, quantum fluctuations can become separated in dramatic ways. One member of a virtual particle pair might fall into the black hole while the other escapes, transforming from virtual to real in the process. This is the origin of Hawking radiation, but it also suggests something deeper about the relationship between quantum mechanics and gravity. Some theories propose that space-time itself might be built from quantum entanglement, those mysterious correlations that Einstein called spooky action at a distance. In this view, the smooth geometry of space-time emerges from a vast network of quantum correlations between elementary constituents. Black holes, with their extreme curvature and information puzzles, might be places where this underlying quantum structure becomes visible. The study of black hole thermodynamics has revealed surprising connections between gravity, quantum mechanics, and information theory. Black holes have temperature and entropy, just like ordinary thermodynamic systems. But their entropy is proportional to the area of their event horizons, not their volume. Another hint that information might be stored on surfaces rather than throughout space. This connection between geometry and information suggests that spacetime itself might be an emergent phenomenon, arising from more fundamental information theoretic processes. Time, in this view, wouldn't be a basic ingredient of reality, but something that emerges when information is processed in certain ways. The flow of time we experience might be the subjective manifestation of objective information processing occurring at spacetime's foundation. As we contemplate these cosmic mysteries, we find ourselves returning again and again to the relationship between observation and reality. The black hole information paradox, the holographic principle, the emergence of spacetime from quantum entanglement. All of these ideas suggest that information and observation play fundamental roles in shaping the nature of existence itself. Perhaps this shouldn't surprise us. After all, we know that consciousness involves information processing, and we've seen how the experience of temporal flow emerges from the brain's integration of sensory data, memory, and prediction. If spacetime itself emerges from information processing, then perhaps there's a deep connection between the mechanisms that create conscious experience and the processes that generate physical reality. This brings us to one of the most profound questions in all of science. Is consciousness fundamental to the universe? Or is it merely a complex arrangement of matter that happens to experience something like awareness? If information processing is what creates both the experience of time and the structure of space-time itself, then perhaps consciousness and physical reality are different aspects of the same underlying process. The quantum measurement problem, the question of how definite outcomes emerge from quantum superpositions, remains one of physics's greatest unsolved mysteries. Some interpretations suggest that consciousness plays a special role in collapsing quantum wave functions, though this remains highly controversial. Other approaches propose that the classical world we experience emerges through decoherence, the process by which quantum systems become entangled with their environments. But all of these interpretations face the same fundamental puzzle. How do we get from the mathematical formalism of quantum mechanics to the rich, experienced world of conscious observers? This is where the question of time's reality intersects most directly with the mystery of consciousness itself. If the block universe view is correct, and all moments of time exist simultaneously in a four-dimensional structure, then what creates the experience of flowing from one moment to the next? Perhaps it's the process by which consciousness integrates information across different temporal scales, creating the narrative structure that we experience as the passage of time. Your brain right now is performing an extraordinary feat of temporal integration. Sensory information arrives continuously from your environment, but your conscious experience isn't a chaotic stream of disconnected sensations. Instead, your neural networks weave this information together with memories of the past and predictions about the future, creating the seamless experience of existing in a flowing present moment. This process requires enormous computational resources. Your brain uses about 20% of your body's total energy budget, much of it devoted to the complex information processing that creates conscious experience. Every moment of awareness represents a significant investment of metabolic energy, suggesting that consciousness serves some important function in the universe's ongoing evolution. Perhaps that function is to create temporal experience from timeless mathematical structures. If the fundamental laws of physics are indeed timeless, as some interpretations suggest, then consciousness might be the universe's method for experiencing its own temporal unfolding. Through minds like yours, the cosmos gets to feel what it's like to move through time, even if time itself is ultimately an emergent property of more basic processes. This perspective suggests a remarkable possibility that consciousness isn't separate from the physical universe, but represents one of its most sophisticated achievements. Through awareness, the universe has learned to experience its own existence from the inside. Through minds capable of contemplating time's nature, the cosmos has developed the ability to question its own foundations. The journey from the quantum realm to the cosmic scale reveals time's nature as something far more subtle and mysterious than our everyday experience suggests. Whether flowing or static, fundamental or emergent, universal or personal, time weaves through every aspect of reality in ways that continue to surprise and delight scientists and philosophers alike. As we drift through these contemplations, remember that you're not just learning about abstract physics or distant cosmic phenomena. You're exploring the very fabric of your own existence, the mysterious processes that allow moments to unfold, thoughts to arise, and awareness to persist through constant change. The question of time's reality is ultimately a question about what it means to be conscious beings in a universe that may be far stranger and more wonderful than we can fully comprehend. The cosmic story of time extends far beyond black holes and quantum mechanics into the deepest questions about existence itself. In the universe's far future, long after the last stars have burned out and the final black holes have evaporated, what will become of time itself? Will it continue its steady march toward greater entropy, or will it fade away along with the processes that give it meaning? Some cosmologists envision a universe that reaches maximum entropy, a state of perfect equilibrium where no further change is possible. In such a cosmos, temperature would be uniform everywhere, energy would be distributed evenly, and there would be no gradients left to drive the processes we associate with the passage of time. Time itself wouldn't disappear, but it would lose most of its significance in a universe where nothing happens to mark its passage. Yet even in contemplating this ultimate fate, we encounter time's persistent mystery. The universe began in a state of remarkably low entropy, with energy and matter organized in ways that made subsequent complexity possible. Why did the cosmos start in such an improbable configuration? What set the initial conditions that allowed time to have a direction, an arrow pointing from past toward future? These questions touch on some of the deepest puzzles in cosmology and connect directly to our ongoing exploration of time's nature. If time emerges from relationships between different parts of the universe, then perhaps the arrow of time itself is a kind of emergent phenomenon, arising from the collective behavior of countless quantum systems as they evolve from simple to complex configurations. The story of cosmic evolution becomes, in this view, the story of time learning to exist. From the first moments after the Big Bang, when the universe was a hot, dense soup of elementary particles, to the present day with its rich tapestry of stars, planets, and conscious observers, the cosmos has been exploring increasingly sophisticated ways of organizing matter and energy in time. Each new level of complexity, from atoms to molecules to cells to organisms to minds, represents a new way of creating temporal relationships, new methods for correlating events across different scales and durations. The universe doesn't just exist in time. It learns to create time through the ongoing process of becoming more complex and more organized. Your own existence represents the current frontier of this cosmic evolution of temporal awareness. Through consciousness, the universe has developed the remarkable ability to experience its own history, to remember its past, and anticipate its future. The questions you're contemplating about time's reality are questions the cosmos is asking itself through the intricate patterns of neural activity that constitute your thoughts. This brings us full circle to where we began, with the simple question of whether time is real. After our journey through relativity and quantum mechanics, through black holes and consciousness, through the cosmic past and the far future, what can we say about time's fundamental nature? Perhaps the most honest answer is that time is both real and constructed, both fundamental and emergent, both universal and deeply personal. It's real as a feature of spacetime's geometry, as described by Einstein's equations. It's constructed as an aspect of conscious experience, created by the brain's integration of sensation, memory, and prediction. It's fundamental as the parameter that describes how quantum systems evolve. It's emergent as the pattern that arises from countless microscopic interactions. The question of time's reality doesn't have a simple yes or no answer, because reality itself is more subtle and layered than our ordinary categories can capture. Time might be somewhat like music. It emerges from the relationships between individual notes. But once it emerges, it becomes something real and meaningful that can move us, inspire us, and transform our understanding of what's possible. Through our exploration tonight, we've seen how time connects the most intimate aspects of personal experience with the grandest scales of cosmic evolution. The same processes that create your sense of flowing through moments also drive the expansion of the universe and the evolution of complexity on every scale. Time isn't just something that happens to you. You're part of time's ongoing creation of itself. Whether time flows like a river or stands still like a sculpture, whether it's made of discrete moments or continuous duration, whether it exists independently or only in relationships, these questions invite us to wonder not just about the mechanics of reality, but about the miracle of being conscious, beings capable of asking such questions at all. The universe has spent nearly 14 billion years evolving the complexity necessary for minds like yours to exist. Minds capable of contemplating their own temporal nature and questioning the foundations of existence itself. Through your awareness, time becomes conscious of itself, and the cosmic mystery of temporal existence gains another perspective from which to examine its own profound strangeness. As we prepare to conclude this gentle journey through time's deepest mysteries, remember that you've been doing more than just learning about abstract concepts. You've been participating in one of the universe's most remarkable achievements: the creation of temporal experience through consciousness. Every moment of understanding, every flash of recognition, every quiet reflection represents time and awareness, collaborating to create meaning from the vast dance of matter and energy that surrounds us. The ticking of clocks, the rhythm of heartbeats, the flow of thoughts, the passage of seasons, all of these are expressions of the same fundamental mystery that we've been exploring together. Time may be the universe's way of ensuring that not everything happens at once, but it's also consciousness's way of transforming the abstract structures of physics into the lived experience of existence itself. In the end, perhaps the most beautiful aspect of time's mystery is that it remains mysterious. No matter how precisely we measure it, how completely we map its effects, how thoroughly we analyze its properties, something essential about temporal experience continues to elude complete understanding. This elusiveness might not be a failure of science, but a reflection of time's true nature, not as a problem to be solved, but as a process to be participated in, not as a thing to be grasped, but as a dance to be joined. Through our contemplation tonight, we've touched on ideas that span from the quantum realm to the cosmic scale, from the birth of the universe to its ultimate fate. We've seen how time connects consciousness with cosmology, how the flow of moments emerges from timeless mathematical relationships, and how the question of time's reality opens into the deepest mysteries of existence itself. As you carry these ideas with you into whatever dreams may come, remember that time's greatest gift might be the very capacity for wonder that allows questions like these to arise. In a universe of flowing time or eternal stillness, in a cosmos of deterministic equations or quantum possibilities, the fact remains that somehow, somewhere in the vast expanse of space and time, awareness has emerged with the ability to contemplate its own foundations and find beauty in the mystery of existence itself. Whether time emerges from the relationships between quantum fields or stands as a fundamental dimension of reality, whether it flows like a gentle stream or exists as an eternal sculpture containing all moments at once, one thing remains beautifully certain. You are here now, consciousness arising within this cosmic mystery, capable of pondering the very processes that created you. The ancient philosophers spoke of two kinds of time that feel relevant as we drift toward the close of our exploration. There was Chronos, the mechanical time of clocks and calendars, the measurable duration that physics describes with such precision. And there was Kairos, the meaningful time of significant moments, the fullness of experience when something profound unfolds within awareness. Tonight, we've wandered through both kinds of temporal experience. We've encountered the chronos of atomic clocks that can detect gravity's influence between your head and your feet, the precise mathematics of relativity that reveals time's flexibility, the quantum equations that suggest reality might be fundamentally timeless. But we've also touched something deeper, the kairos of wonder itself. Those moments when understanding dawns and the universe reveals another layer of its extraordinary nature. Perhaps this is why the question of time's reality resonates so deeply in human consciousness. It's not merely an abstract puzzle for physicists to solve, but an inquiry that strikes at the heart of what it means to experience existence from the inside. Every breath you take unfolds in time. Every thought that arises exists within temporal flow. Every moment of love or beauty or quiet contemplation depends on the mysterious process that allows one instant to give way to the next. The universe began as pure energy in a state of almost perfect simplicity, and has spent eons exploring increasingly complex forms of organization. From that primordial fireball emerged space and time, matter and energy, stars and planets, chemistry and biology, and eventually the intricate patterns of neural activity that constitute your thoughts right now. In this vast story of cosmic evolution, consciousness represents something unprecedented, matter organized in such a way that it can contemplate its own existence. Through awareness, the universe has developed the remarkable capacity to experience its own temporal unfolding. The questions you've been pondering about time's nature aren't separate from the cosmic processes that created you. They're expressions of those processes, the universe examining its own foundations through minds capable of wonder and reflection. This perspective transforms our understanding of what it means to be conscious beings embedded in time's flow. You're not merely observers watching the universe unfold from some external vantage point. You are the universe unfolding, temporary arrangements of matter and energy that have somehow learned to experience their own existence, to remember their history, and to imagine their future possibilities. Every moment of awareness represents a kind of cosmic achievement, the transformation of lifeless matter into living experience, of mechanical processes into felt meaning, of abstract mathematical relationships into the warm reality of consciousness. Through your thoughts and feelings, through your capacity to wonder about time's nature, the cosmos gets to know what it's like to exist from the inside. The implications ripple through everything we've explored tonight. If consciousness participates in creating temporal experience, then perhaps the boundary between subjective and objective reality isn't as clear as we once imagined. The flow of time you feel might be both discovered and created, both given by physics and made by awareness working together in ways we're only beginning to understand. Modern physics has revealed a universe far stranger and more wonderful than our ancestors could have imagined. Space and time are woven together in a flexible fabric that can stretch and bend. Quantum mechanics suggests that reality exists in superposition until observation collapses possibilities into actualities. Black holes warp space-time so extremely that cause and effect, past and future, lose their ordinary meanings at the event horizon. Yet for all this strangeness, for all the ways that science has revealed the universe to be far more mysterious than it appears, something familiar remains. The experience of existing in time, of having thoughts arise and fade, of feeling moments pass with their unique qualities of joy or sorrow or quiet peace. This continues unchanged by our growing understanding of time's deeper nature. Perhaps this is because experience itself is what transforms the abstract structures of physics into lived reality. No matter how completely we map the mathematical relationships that govern temporal flow, no matter how precisely we measure time's effects or analyze its properties, something essential about the felt experience of duration will always require consciousness to make it real. The dance between physics and awareness, between the objective structures science reveals and the subjective experience that gives them meaning, might be what creates the rich tapestry of temporal existence we inhabit. Time needs consciousness to be experienced, but consciousness needs time to unfold its complex patterns of thought and feeling. As we reach the end of our gentle voyage through time's deepest mysteries, perhaps the most beautiful truth we've discovered is that the question itself, is time real, might be more profound than any single answer could contain. Time reveals itself as both the most intimate aspect of your experience and the most elusive feature of reality, simultaneously the foundation of existence and its greatest puzzle. Tonight, we've drifted through realms where seconds stretch toward infinity near black holes, where quantum particles dance through multiple moments simultaneously, where consciousness weaves temporal flow from timeless correlations. We've seen how your heartbeat creates biological time, how memory gives the universe its arrow, how awareness transforms abstract duration into lived meaning. Through it all, time remains both utterly familiar and completely mysterious. So as you settle into whatever dreams await, carry with you this gentle paradox, that in questioning time's reality, you've participated in one of its most remarkable achievements. Through your wonder, through your capacity to contemplate these cosmic mysteries, time becomes conscious of itself, whether it flows or stands eternal, whether it emerges from quantum relationships or weaves the fabric of spacetime itself. Time has found a way to experience its own existence through minds like yours. Rest well, knowing that every moment of awareness, every breath, every quiet reflection represents the universe discovering what it means to exist in time. Until we meet again under these whispering stars, may your dreams flow gently through whatever temporal landscapes they choose to explore.